Good morning. We're so close to the end of the semester. Oh my God, so close. We can do it. I believe in you. I do have a couple announcements. I have posted a tentative schedule in terms of like what's going on during that week and specifically what's happening on that day. I already had to mess it up a little bit. Literally as soon as I posted this, I got a call and I've got my 6-month full scan on Thursday morning. So I have to do that. That's not a debatable one. It should happen before class starts, but I don't know what kind of scan it is. If it's an MRI, it'll only take 15 minutes. If it's a PET scan, it'll take 2 hours. So I would ask you to come to class on Thursday. If I'm not there by, well, I can text you guys, one of you, and let you know what is happening. If I'm there, or I'm back, that's what I'm trying to say. If I'm back quickly, then I'm gonna do the demo that I planned for that day on that day. Otherwise, I was thinking I would do it today. I don't think that's gonna happen. I'll move it here, and I'll do multiple demos in the same day. I'm trying to give you 2 work days right at the end. I don't know when our final is yet. They haven't posted the finals schedule specifically. They have posted that finals week is the 5th through the 7th, the same way it was last time where it wasn't a full week, it was this like ultra condensed thing. So my guess is our crit will be on Thursday morning at 8. Yeah.
I think they did it yesterday.
Did they finally?
Because I think one of my teachers was telling us what time it would be.
Great, wonderful. When I was making this up, they literally hadn't posted it yet. So, of course, as soon as I put it up, things change. One thing I do have on here though is shop cleanup. Shop cleanup that Friday at 10 a.m. It's usually 10 to 2. It takes about 4 hours to do the whole shop in its entirety. If for whatever reason you can't make that, you just have to let me know. And I'll come up with some alternative plan for you. But it is a mandatory requirement as part of our exam. It's sort of the only time, typically speaking, when everybody has been able to do it. So if you can't be there during this time, let me know. We'll come up with some other time for you to do your share of the work for it. Yes? Sound good? Make sense? All right, I will look up when our specific exam time is. It will be up here. It'll just be a critique like last time. And again, any completely incomplete work that you may have will be due at that point. Although most of you have turned in project number 1 at this point and have all done, y'all got A's on it, man. It's crazy. I could talk to you about the individual nuances of your projects, but every one of you just nailed it. It's crazy. Not a surprise though, not a surprise. Every one of you worked super hard, so yay. Some of you bumped your grade up to an A by going back and doing more work on it. So anyway, today we're going to talk about how you actually cut miters. Huzzah! So that's the thing we're going to learn. You may want to get a little closer in terms of being able to see what I'm doing. By all means, array yourselves appropriately. So I've left these couple of examples sitting out so that you can all kind of see varying sizes and possibilities and whatnot. This is a reasonable scale for this project. I know most of you have worked past this point by now of like knowing what you want to do and working on sizes and things like that. I just want to remind you that the width of your stock is going to become really important in terms of the ease of executing this whole thing. If it's something really, really narrow, It can be problematic only in that we can't get a biscuit in here. I'm going to show you guys biscuit cutting later, which is an interior spline. It's this little piece of wood that fits inside this joint and just strengthens it a little bit. Mind you, most of the time you probably don't actually need something to back up your miter joint unless it's something that's going to have a lot of stress put on it. So since so frequently these are for frames and frames hang on a wall and don't really take a lot of stress, backing them up with something isn't super critical. If it were something more structural though, you know, part of a piece of furniture, that kind of a thing, you would want something additional in there. So I'll be showing you spline cutting as well, which is an exterior support when we do the other stuff. This really is the maximum size, I would say, for what you can get a decent miter in, and even then, it takes a lot of doing in terms of making this perfect. Always, every morning, Tuesday morning, there goes the trash. Where was I? Ah, yes. So this piece, I think, what did we decide on? This was 4.5, something like that?
I think so.
Yeah. This frame itself is about 18 by 18. Nothing too spectacular that way, but it's the length of this miter that I want you to take note of. I know I mentioned it before, but remember, like, the longer the miter is, the harder it is to fit in relation to all these other things. So this guy, not too difficult, because there is less surface area here that has to be accurate. I will also tell you this, there's a reason why both of these are square. And that is, it's really much, much easier to fix a square when something is out than it is to fix anything else. So these are also the end result of a demonstration I did to show people how to fix a bad joint. I think if you really looked at them, you'd find that they aren't actually perfectly square, that they're out by a degree or two in either direction. But regardless, just bear that in mind as well when it comes to fixing the things. But anyway, you all are pretty much to the point where you've got your designs, you've figured out the sizes of the pieces that you're looking at, you're prepping your stock, right? Assuming you're making a frame of some kind, even for those of you who aren't, the process is still kind of similar. You're just going to not have to do quite so many steps with this. The first thing that I do before I cut any of my joints, after I've got my wood prepped, is I decide what goes where. This is a big, important step. I want it to look good, right? And depending on how I, set up my pieces, oh, it's one of those horrible pieces. Purple. Anyway, depending on how you set it up, you can actually reinforce, like, a visual balance, or you can make it look, kind of crazy, or you can reinforce a design depending on what you're doing. So, for example, let's say that your boards have a lot of diagonal movement in them, like just a ton. Depending on how you orient that within your frame, it's going to depend a lot on how it's going to look when it's done. So maybe I will orient it so that I've got, the grain kind of doing this on either side. So it feels a little bit like it's bottom heavy, for example. Maybe I've got grain that's doing this kind of a thing. And depending on what I do, I can make it feel a little bit like it's swelling, If I'm going to cut the whole thing into a shape, perhaps I spend some time figuring out what half of the wood is going to reinforce that design that much better. Like if this, for example, if I was just going to come in and cut my corners out or the outside edges, I'm probably going to want my my grain to echo that as much as possible, right? So I take my time and I look at all of my boards and I flip them around and I do whatever I need to decide what goes where. And I would suggest that you do this before you do your second milling. The reason I say that is because when you go to cut your miters, you need to have your reference surface to the inside, right? So before you cut your boards to width, it would make some sense to know what's going to go where based on, you know, that milled surface. And then mark what you need to make sure is joined for your reference surface, so that when you go to the table saw and cut the outside, you're doing it in a controlled way. Make sense? Yeah? Great. I'm going to pretend with these, though. You literally lay them out, turn them around, take a look at what's what. You know, make a decision. This, obviously, I don't have anything going on too much that's interesting. Once I have everything figured out where it needs to go, though, I label everything. And I think I've gone over this before, but, you know, I don't know. I say to myself, top and bottom. I like to label everything so that when I'm looking at it, if I can read it, it's correct. You know what I'm saying? So if everything is where it should be, it says top, it says bottom, it says left, and it says right. In that orientation. If I can spell right, there we go. Make sense? Now I know what goes where. Top, bottom, left, right. Gorgeous. And these interior surfaces are my reference faces. So, reference. I know I'm driving that home a little much, but it will be very, very important afterwards. Then, the next big thing that I do is I take a look at every single one of my joints, and I label the left side and the right side of the joint. So, if I'm looking at this guy right here, this is the left, that's the right. Turn it here, left, right. Turn it again, I'm looking at it, left, right. That's important. If you gotta keep the left and right sides of your joints straight. If you don't, you're gonna have a problem. So let's pretend for a moment that, oh no, those are somebody else's. This is my sample here. I've got my reference sides marked. I'm gonna do a left side and a right side of this joint. L and R. From here, I'm ready to go to the table saw. I would have this marked on all my pieces. So let's go over to the cross-cutting saw, and we'll move on. All right. So for those of you who have been checked out on the table saw, which is most of you, you'll remember that we cut everything to its finished length on this table saw, right? That's how these two things are the same size as one another, as they went through this cross-cutting process. I know I mentioned it before, I will mention it again, that when you're doing your frames, you don't need to make them perfectly square on the ends first. You can leave them long. The process of cutting your miters is the process that cuts everything to its final length. So don't get too worked up about it in terms of everything being perfect before you start. It's actually harder to make everything perfect the way you need to if you get rid of all of our extra room by cross-cutting it to length first, okay? So, for table saw checkout, you guys learned on this cross-cutting sled. For the miters, we've got this one. Now, this sled is imperfect. It's still not bad. But the idea is, of course, see, it's got a support on it that holds everything ostensibly at 90 degrees to one another. Of course, wood moves, and wood likes to mess with us and say, but no, Sarah, I'm not going to do that at all. And you say, but why, wood, why? And it says, because I'm a terrible human being. In fact, I'm not a human being at all. I'm a big, stupid board. And you say, okay, big, stupid board, you piece of, and you just hope for the best. Anyway, what I have here is what is, like I said, ostensibly 90 degrees. That will change depending on the time of year, depending on how rainy it is outside. Even though this is made of plywood, it just loves to be contrary. It is, at the moment, not terrible, but it's not great either. It's off by about 1/4 of a degree, which doesn't sound like much, but over the course of multiple cuts, you got to remember 1/4 of a degree over 4 cuts is 1 degree. And 1 degree is typically visible within a joint. So those are the kinds of tolerances we're talking about. With that said, the closer you are to the blade, the more accurate it is. Very, very much so. Just like with, again, with the cross-cutting and seeing how everything wants to kind of move, it's much more accurate the closer you are to the blade. So I've come up with the following method for making your cuts and having them be pretty decent, okay? So for example, you are going to begin by cutting the left side of every one of the joints, regardless of whether or not they're going to be the same when you're done or not in terms of length. Just going to clean this up a little bit. So how I do that, just like, again, what we did in checking people out, you start by raising your blade to an appropriate point. I also want to point out, just at this juncture, do you see how much room there is between the front of that peak and the back of the sled there? That is that limit, physically, for how long your miter can be. You know, so that's not much more than 4.5, 5 inches. But, you know, it's not more an issue, of course, of distortion than anything else. Now, if you are at all nervous about maintaining your boards, if you're unsure for any reason at all, check this for square. This is a blade that occasionally gets angled. And so the proper way to do it, of course, is to raise the blade to its highest point and look for distortion. And I'm not convinced this is 90 right now. So I'm going to raise it up all the way. Take my combination square and double check it. If I've got an even reveal, if it's spaced between the carbide teeth, if I can see that there's no, you know, distortion top to bottom, it's probably fine. To be fair, I'm having a really hard time seeing it this morning. Let's see. But I have to do it on the sled, otherwise what's the point? I think it's okay. We'll double check it. Yeah, it's okay. But if this is out even a little bit, what you're going to end up constructing is a spiral. It's going to climb instead of sit flat. It's just this really minor thing, but oof, boy does it matter. You'll also notice that the back of this is not cut all the way through. That's very intentional. Please do not cut all the way through this sled. I will have to rebuild it. You shouldn't need to though. It's going to be pretty obvious pretty quick what you need to do here. All right. So I will definitely need to set this up so that this is more visible. You guys are probably going to want to come closer for this part. Let's see. There we go. Hey, that's a surprisingly good shot right there. So, what I will do when I want to set up my left side, you guys remember how when you were making the crosscut, how the important thing was keeping that board from sliding from side to side? That was a huge, huge deal. Well, I eliminate that variable right off the bat by once I've got my board pushed over far enough that it's crossing the blade, so I'm going to get a full angle on it. I just set up a stop so I can pull against something. I want you to be careful with your clamps in relation to this. People have cut through metal clamps before by having them too close and then not paying attention, or any number of other things. So you don't have to be super accurate about it because you're just trying to get it so that this board has something to pull against as you're cutting. And then you're going to go all the way past. Okay? So, plug your ears. And I want you to watch how I'm standing and how I'm holding this. Okay? And again, going to be to the left of the blade, but how I'm holding it is pretty particular. Okay? All the way through, but you have to go past. There, that is. This is important. Hang on to your triangles. These offcuts are going to become very useful. I'm going to do that on every piece. So if I've got two pieces, for example, that are going to be the same size, such as, I just go ahead and do, I can leave the stop up there for whatever. It becomes, we adjust the stop on this side when it comes time to do the, when it comes time to cut the other side. Anyway. Close to the blade, which is a little nerve-wracking. If you're at all concerned about it, you can clamp your board to the fence. It's just a little bit more difficult to do because either you're like this and then you're in line with it, or you can do it like this, but trying to lock something down that low has the tendency of making this front edge flip up. So you'd have to also push down on it to make sure it's actually sitting flat. Does that make sense to everybody?
So what happens if your board's too long and you can't use the stop?
If it's too long and you can't use the stop, then I usually put a clamp on it. But I'm able to do it far enough back that I can not worry about cutting into my clamp. And then I just put pressure down to keep it down. That's a really good question. Yeah. So I can clamp it back here. It's not a big deal. It just, the important part is making sure that it just doesn't ride up as I'm clamping, because that happens a lot. So, all right, so that's the left side. Normally, and I didn't do this step, I don't know why, but I didn't. I'll double check this for 45 as I'm cutting, so that if it's wrong and wrong by only a really small amount, I might be able to correct that by doing things like putting pieces of tape on the fence itself to kind of, you know, change that angle a little bit, consistently especially. So I take my combo square and I extend the ruler out to the long way past the 45-degree side of it. And then I put that on my miter, and then I compare the outside plane to see how accurate it is. That looks really freaking good. I'm sort of shocked at how good that looks. Let's see. That one, it looks slightly less good. Another thing you can do is you can take your two pieces, even though they're not a side that's going to go together, but you can now check it for 90. You know, the idea is that they're going to come together and be 90 degrees. So, how close are we? And we're off. Can you see how that gap right there? That is not an insignificant amount. You can come around and look. Do you guys see that? That's a fairly sizable gap. So, knowing that, this is in theory 90. So what should happen is if this is off by half a degree on this side, it's going to be off by that matching half a degree on the other side. Make sense? That's why we always do left and right instead of just cutting left side, left side, left side, left side. It's because this is the relationship that's more important. So now we're going to try to make it correct. All right? So once you've cut your left side, then what you're going to want to do is measure out for where you need that other miter to be, mark it, and set up a stop for it. So you can be pretty accurate at this point, and you should be. I'm going to say, for the sake of argument, that I want my piece to be, let's say, 8 inches long on the outside, or 9. Let's do 9, because that will give me just a little bit right here. I'm going to cut an inch off. So you may recall also from table saw checkout the way that we mark everything. In this case, it's going to be important to have it marked on this front leading edge and across the top. But whatever is the important part, that's the part you measure. So if you're like, well, I don't care how big this is on the outside, but I know that this interior space has to be exactly blah, blah, blah. So you measure that and you mark that. But it's the same thing. You put your pencil on the line, move your combo square up to it, and just make a quick mark. Just exactly like I did in demo. And just for good measure, I am going to put one on the inside here too, just for good measure. Then the important part is, of course, setting this up. And once again, just like in the other one, we line it up so that it wants to touch right at that line there. And then I need a stop on this side. The problem with putting a square stop up here is that as soon as you put a little pressure on it, it rides. See that? That's problematic. That is why we have one of these. Ta-da! See how it says do not trash? That's for a very specific reason, and that is to back this up right here. It makes it a little easier to keep everything from moving around if you've got this little dude. If this one is too hard to clamp because it's not very tall, we do have other 45-degree pieces kicking around on the saw stop. These are part of another setup. but they will work as well. And in fact, will be easier to put a clamp on. So, again, I'm gonna move this up. I'm gonna put my clamp on it. Yep, looks good. And you can see though that this, like these two angles aren't perfectly aligned. I can move this against it a little bit. So the thing that I'm trying to do is just hold it against here and, but still hold it tight to this surface. Right. I'm gonna make these cuts real quick. So again, just like with your test cutoffs, you do opposing sides to get them with the same stuff, to get them exactly the same length. So what I have now should give me something approximating 90 degrees. We'll see. Push this back a little bit. You can see it better. Yeah, that's actually pretty damn accurate. So that's why we're using both sides of the fence like that, or both sides of the sled. Is this compounded here makes 90. By itself, it really just doesn't. It's one of the foibles of this particular sled. Not every sled is going to be like that. Some people have much more beautifully calibrated things, but alas, we don't. The fact that we have this one is kind of a miracle. So anyway, you're going to end up with two pieces that are the same length on one side. Hi. The same length across from one another this way, and then two pieces that are identical across this side. Just adjusting your stop to make that happen. Once you have that and have everything appropriate to how it needs to be, then it's time to actually figure out how to glue these things together. Because this is a half-strength joint, you could, in theory, like I said, just glue it up and call it good and say, ta-da! Most of the time, though, it's, especially the wider you get, you do need something additional in there to, to keep it all completely attached. So we touched really briefly on splines. Splines are those, it ends up looking like a little stripe on the corner, right? In order to execute that, you do have to glue everything together first. And then you take your completely assembled thing, and on a special sled on the table saw, we run it over the blade to make a space, and then we stick a piece of wood in there. The one I'm going to show you today is the biscuit cutter, which is going to produce an internal piece that you're just not going to see. The only thing you need to really remember about the biscuit cutter is that if you're going to carve really deeply into your material, you got to make sure you're not carving so deeply that you're cutting into the biscuit slots. So, questions at this point before we go on to that? All right, pause. There we go. Okay, so once you have all of your pieces cut, you are ready to biscuit cut them. So what are biscuits? These are biscuits. These little dudes right here. These are pieces of compressed lumber. In this case, it looks like it's beech. That has been cut into kind of an almond shape that fits directly between the joint, right? Into a slot that we make with a blade that has the same diameter, or the same radius, that's what I meant. Biscuits typically come in 3 sizes, 0, 10, and 20. I'm out of zeros right now, but I have 10s and 20s. But here's the thing, just because I'm out of zeros doesn't mean I don't have zeros. Because this has a blade in it whose diameter never changes, right? That blade stays the same. The thing that is different every time is how deep you plunge in to make your slot. What that means is that if you really look at your biscuits, they have the same profile on one side, on each side, actually. It's just a question of how deep they are. So if I need to make a smaller biscuit because I need a smaller slot, I can just take a bigger biscuit, so this is my 20 for example, and go over to the sander and turn it into a smaller biscuit. See that? Hopefully. I hope you can see that. I can't see it. But the 0 would be the same thing. It would be even a little bit smaller. So don't be weirded out. These are kept in those green drawers in the glue room on the very right-hand side. Top, middle, bottom. Tops are 0s, which is why that drawer is empty. Middles are 10s, bottoms are 20s. So this is the biscuit joiner. It's also referred to as a plate joiner. It is also occasionally referred to as a lamello. Lamello is a brand name. They are the company that invented this object. It's a genius design. This thing is super smart. The whole idea is that when you push here, there's your little spinning blade, right? And it creates a slot. You can do this in almost like any surface with any, lots of different applications. This is used a lot actually for referencing like 2 things coming together side by side. If you want to make sure that they can't slide this way, it's really useful. I find for myself that I don't like setting it down on things and using it. I like to reference off of this fence here. So I'll set this fence all the way down at 90 degrees. And that way, irrespective of whether or not this thing is sitting flat on something, as long as I've got it referenced against this plate, it's going to be consistent. Now, this is not the greatest quality object here. Like, this thing has seen some wear, some use. So you have to be a little careful with your cuts. If you just sort of think to yourself, oh, it's going to be fine, probably won't. But if you take a look right back here, there is a dial that says 0, 10, 20, and M. You want to make sure that the red line is lined up with whatever the depth is that or the size of your biscuit. In this case, I'm going to turn it to 10. And it's a little on the sticky side, so just be aware that that's, if you're like, it won't turn, it will, you just have to push. So that's controlling the depth of my cut. The fence in the front controls its relationship to whatever it's cutting. So if, let's say I was wanting to cut a miter this way, I can actually set this at 45 degrees and set it up and make a cut. That's a thing. In this case, we just want it at 90, straight down. And then on the other side here, this controls the height, the relative height of this fence. So you can raise and lower that slot accordingly. You'll notice there's a little red mark on the side here. That shows you pretty close to what that actually ends up being in terms of the distance. Depending on what you're cutting, you're probably going to want it to be fairly close to the center. Some exceptions to that are, again, if you're going to do a lot of really deep carving into something, you might not want it to be quite so close to that surface. You might want to drop it back a little bit. Likewise, if this isn't very wide and you've got big rabbets that are going to go in this, again, you might not want to have it quite so close to the bottom. Maybe you want to move it up closer to the top at that point. I am just going to put my piece up here, and you can see it's like nowhere near where it should be for that, right? And just make my adjustment until it looks right to me for something roughly centered. Come on, you. Wrong way. Why won't you go the other way? It's being stubborn. There we go. There we go. Okay. A lot of people forget to tighten up these adjustments. If these little dudes aren't tight, it will slip as you're using it. Please don't do that to yourself. There's no reason to. So you know you can eliminate some difficulty just by having it be nice and tight. So this is now all set up in terms of cutting appropriately for what I need. What I need to do now is make sure that I have everything marked appropriately on my joints. So I like to take my number 10 or whatever biscuit I've got, and I have to have a reference mark on the top surface of where I'm cutting. You'll notice that there's a little divot right in the middle of the plate here. There's one here and one here. That's the center of that cut. That is what I'm referencing. I'm lining it up so that that thing is right on that mark, and then I can plunge in and make my cut. If I do it matching on both sides, then I should be golden. The problem happens if you are twisted for whatever reason, then you get a diagonal slot like this. Or if you are up at an angle too high, that happens a lot, or down. It's going to change height, it's going to change angle. So I'm going to show you a way of cutting that is not how this was intended to be used, but is a hell of a lot more accurate. So anyway, but what I will do is I will set my biscuit on here and just sort of say to myself, all right, well, that looks pretty good. And put my pencil on what I perceive to be the center, and then just make a quick mark across like that. See that? Do yourself a favor, do not put the marks on any other surface. Don't put them here, don't put them on the back side. Only, keep that orientation that I was talking about before, and only make your marks like that. It helps to avoid confusion a lot. If for whatever reason you do miscut your slot and you need to fix it, the way that you fix it is you just glue a biscuit into it and let it dry, and then we cut it off, and it's okay. And then you just redo it. So if you mess it up, please relax. Please, please, please. And in fact, it's helpful to size up for what you're going to put in there for a patch, because these slots actually are wider than the biscuit itself, so that there's this little bit of play in there, okay? Remember that. So if you have very, very little room, like right now, you might say to yourself, oh, I could fit a 20 in there. In theory, you could, but that slot is going to extend past the ends by a good 1/4 inch on both sides. So I'm gonna say, no, you don't have room for a 20 in this one. I do have room for a 10. I definitely have room for a 0. I don't have a 0 sitting here, so whatever. All right, so I've got it marked. We all good so far? So the biscuit cutter itself makes a ton of noise and a ton of mess. So you definitely need your safety gear for this. You can hook this up to the vacuum dust collector. It's not hard to do. There are several different attachments that you can slot into the little vent right there. See that? I'm gonna swing you around. Hello. Hopefully it's not too glary. But you guys remember the orange fine vacuum here? This is the one that we just used for dust collection. I finally got it working. I had to replace the switch on it. Or not, sorry, not the switch, the cord. The outlet prong thing so that it would work. But now it works. So, just pop that right on there. Look at that. And then you plug the biscuit cutter into the vacuum itself. And that should, yep, do that. So it's gonna help keep the dust under control. I think I might need to empty that. I think that's the point that we're at with that because it's starting to not suck very well. The sucking is sucking. Haha. All right, so the other really big thing here is to make sure that whatever it is that you are working on, that there's no interference. So I don't have this up on the table in such a way that it might, you know, that I'm gonna have to fight with this little dude, for example. I need to make sure there are no clamps in the way that are gonna keep me from being able to use it. If your pieces are long enough, it's actually not too difficult to, move this out of the way for a second. I like to go to a corner, typically, if my piece is long enough. Imagine, if you will, that this piece is like super, super long, so that I have an end hanging off over here and an end hanging off over here, and I can clamp it there and there. So it has 2 points of contact, isn't going to want to pivot, and doesn't have clamps in the way. That is how I like to do it. Because I don't have that as an option for this, I'm going to put it in the vise and hope for the best. One thing I have to make sure of is that the board is above the top surface of the table though, right? And then if it wants to pivot for whatever reason, I can put something underneath here to keep it from being able to push down. So before I do this, I'm just gonna make sure that I actually have it working for what I need. And I'm running up against the table here, just a tiny bit. I'm gonna pretend that that's not the case and make my cut anyway. Otherwise, I do probably need to come out just a little bit. Well, I probably need to come out just a little bit. I'm reluctant to change too much on here. Because I'm not putting too much pressure on it and I can feel it moving already. So, I'm just going to start kind of patting it out underneath to keep it from going anywhere. All right, so a little thinner than that guy. I think he'll work. So now if this wants to rotate down, it has a limit to how far it can go, right? And in fact, I'm gonna reinforce that even further with a couple of shims. If you take 2 shims and you put them opposite one another, you can keep a parallel surface as you adjust things like this, right? So I can put that under there and then make sure that it doesn't want to go anywhere by shimming the other side, but it also just doesn't seem like it wants to go anywhere. All right, so the way that I do this in terms of how I hold it, which is the way that you're not supposed to do it, but it's how I do it. You'll notice that there is a handle on top, right? I'm going to just take this off for a second. Handle on top, trigger down below here, right? You need to make sure that before you start, you haven't pushed so hard that the blade is exposed. okay? Because if you do, it's gonna take off across that surface. It's just gonna climb it, okay? So it has to be in kind of a neutral position. What I find is if I hold it like this, the likelihood of me tipping it up or pulling it down too far is very high. So instead, I put it on that surface. Can you see this, computer? I find where it needs to go, and then I put my hand on the front of that guard there. And it keeps it in line every time. So I can kind of find that sweet spot by tipping it up and down. And then I hold that in place. I can turn it on, plunge, pull back out, and it's good to go. All right? So why don't you watch me do this? And yes, it's going to make some sounds, some very strong sounds. There we go. So this is what has yielded a nice, flat, parallel thing. And you can see when I put my biscuit in here, there is room on either side. See that? Okay. I'm going to go ahead and cut the right hand one exactly the same way. Get in there, you. Making sure, again, that I have enough support here. I'm not convinced that that's... Come on. There we go. Aha. Take your time to do this right. Saves you a lot of time of having to recut a bunch of stuff. Because, I mean, yeah, it's fixable, like I said, but would you rather fix it, or would you rather do it right the first time, ultimately? I know, I would rather do it right the first time and not have to mess with it later. There we go. All right, other one. There we go. So I should have a matching slot now on this side. Ta-da! Let's see if I can get them to go together. Put the biscuit in the middle. Yes. Now you'll notice that it's not like it's holding the whole thing together in and of itself. It's not going to. Until we've added glue. Remember, the glue is water-based, and it is going to cause this joint to swell. This in particular. So we get this thing a little bit wet with some glue, and it's like, whoop, and then that guy is not going to want to go anywhere. So typically, if I've got all four sides and I'm able to do it in a single go, I'm going to use a ratchet strap to pull everything together. I've got these clamps that are essentially just ratchet straps that you click together. I wanted to show you how to do this though, if you need to do it one side at a time. that will sometimes happen. If you have to fix your corners, like if you've tried cutting and cutting and cutting and you can't get it good, frequently what you'll do is you'll say, all right, well, I'm gonna pretend that these two sides are perfect, and you glue together opposite corners. And then you recut your sides on the table saw in a different way, which I will show you later. But that is when you need these. We use these as glue blocks to help get perfect clamping pressure across this. So let's go into the glue room and I will show you how that works. Resumed. Okay. So if I have to do these individually, that is what the little corners end up being really, really useful for, is I end up hot gluing them to across my joint so that I am able to put clamping pressure on here, you know, in a halfway decent way without it either splaying or, you know, some other such thing. Like I was saying before, ideally what you do is you use a strap clamp. That's what these guys are. They look just like truckers come-alongs. That's what they are essentially. But instead of being in two pieces, they're in one. See this? This one is already strung, but I'm going to show you how to do it anyway. So, are you guys familiar with the idea of the ratchet strap? So, what you're going to have is a big long strap, obviously, and a crank on here. Goes back and forth, ratchets this little center section here. You can see how it's moving. Different, right? What you're going to do is take the strap, making sure it doesn't get twisted, right off the back here. Just pull, pull, pull. Take that end and pass it through the center of that arbor and then back out. This flat surface here is the inside. This is the part that's going to stay still and move across that top surface while this handle, you know, moves around. Ryan, would you grab me like the big bathroom mirror off the table there? Thank you. So if I were gluing this up, for example, what I would do is I would get all of the glue in my joints, get everything fitted how I needed it to be, and then put something like this, you know, down on here, making sure it's not twisted, all that good stuff. Which can take some doing. You know, this is what you do in your dry run, is you get your strap clamp like ready to go. So do you see how I have it pulled up now? I've got put, you know, not twisted, roughly the right spot. I put a little bit of tension on the strap, and then you start cranking it together. That's going to pull the whole thing together, and that's it. That's your process. If for whatever reason, like especially if you've got really long ones like this, long miters, if they don't want to be flat, if they want to twist on you, you can take clamping pads, right? As long as you've got a good plasticized surface here, or a piece of paper, or something that's going to serve as a resist, you can use the tabletop surface as reference as well, and do things like clamp this to the table, right? Keep everything nice and in place. Or if you don't want to clamp it to the table, you sandwich it, 1 and 2, and clamp it to itself as well. That will help keep everything in plane. That'll be the last step though, after you get this kind of clamp on here. In terms of how to get these clamps off, there are little levers on both sides. that when you pull them, they release and don't turn your crank any further. What you do is you open it up by, moving this little dude over, and then pull. Actually, I take it back. What I do is I put a little bit of pressure back on this to take the pressure off the backside, and then pull the lever to the inside there. And that should release the pressure enough that you can then release this one. That's the one that holds this guy in place. And that's it. Just make sure that when you put these back, you aren't, don't put them back all wound up around the arbor. Like, reset them. I find it's nice to just leave it like that. And then instead of trying to crank this closed, use the switch. Use that little release on there so that you can move it without cranking it. Then you just wind it up. So, put that aside for the moment. And then it's the same dry time. It's the same glue, so it's the same dry time. All right. So how do we do something like this? One thing I like to do is make a line across my joint to show me where that perfect center is, right? I don't want to be clamping up here. I don't want to be clamping down here, right? I want to have clamping pressure perfectly across this joint. So sometimes if I've got a really good cutoff, literally all I'll do is like flip it over and reverse it and know that like I need to glue it right there to make the bow tie. See what I'm saying? But I don't want it way up here. I don't want it way down here. I want it right across. And that way what I can do is I can put the clamp directly across here. So I'll probably put it just slightly above center, because as I am pulling this way, or as I'm pushing this way with the clamp, I want to make sure that it doesn't want to just pop right off, right? So if I put it up a little higher, that lets me put a little bit of clamping pressure on it here without breaking this glue seam. Do the same thing. The other way to do this is, of course, with the combo square to mark diagonally across it. All right, here's an important section here though. I have got my hot glue gun on high. You have to make sure that you are using hot glue, okay? You can't let it cool down while you're in the middle of doing this, so don't like stick hot glue on all your corners and then try to pop them on here. Do it one joint at a time, do it one piece at a time. I like to do this where I've got the grains still also lined up here for that same reason that I've got better surface connection. So I have let my hot glue gun get real hot. It's leaking glue. Let's see, can you see that? Ish. I put a pretty generous amount on the side there, and I immediately push it against my piece, making sure that both of them are flat on the table. If this is twisted, that's going to keep me from being able to keep it flat on the table when I'm doing my glue up. And then I let it sit there. Like, you have to then let this cool completely before you can put any clamping pressure on it. If your glue isn't hot enough when you do this, as soon as you start putting clamping pressure on it, it's going to break. And it's going to suck. And then you'll be like, I have wet glue on this and I don't have any way of putting clamping pressure on it. Oh God. So again, big generous blob and immediately onto the table. Give it some good pressure and then just let it cool. I leave the glue gun plugged in while I'm doing this in case I do need to reattach this mid glue up for whatever reason. But in the meantime, you just let it dry, let it sit there. I will occasionally pull it off the top like that while I'm sitting and waiting. I can let it cool off the rest of the way, just like that. If you're at all concerned that you have glued something to the table, ever, twist the work. That is the way to break that seal. Alright, so we will let that sit. So now I will be able to get a biscuit in there and then get a clamp directly across. And that's what this mark ends up being really good for. So I can, and you don't have to put a lot of clamping pressure on it either. If you over clamp this, it will come apart or it'll slide. I barely have this closed. That is what I'm looking for. Just enough clamping pressure that this is going to come together. So there's one more thing that's really important to know about assembling something with biscuits, and that is that when they swell up with glue, you cannot get them out with your fingers. Good friggin' luck. So I make sure before I start that I have a pair of channel locks on hand. These dudes right here. I have a couple different pair, a couple different sizes, doesn't matter what size, but this mode of plier will let me, if this gets stuck for whatever reason, I'll be able to get this on here and pull it out. I will not be able to grasp it with my fingers and do it. It's just not possible. So, gluing this up. What I will be doing is putting glue in the slot on one side, putting the biscuit in, letting it push some of the glue out, putting that on that surface, putting glue in the other slot, and then putting it together, which I realize is not a great description, but because it starts to swell right away, I really do need to make sure that I'm not over gluing. I do, however, need a new brush. So if I was doing this fully, with all four pieces, I would do it exactly the same way. But the likelihood would be that I would do corner, the other piece here, and then I would set it up and do 1, 2, drop that one on. Real simple, but let's see. You're gonna work, the time is 9:32. Bring you a little closer to see this action. See if you can do this. Yeah, you got it. All right, so, like I said, glue in the slot. Not a ton. Kind of spread it around there. Get in there, you. And immediately, biscuit in the slot. From there, a little glue on the surface. And it's okay if it makes a giant mess. Like, it's not a big deal. But do you see how I'm not intentionally putting glue on the biscuit? If it gets on there, it's not the end of the world, but I'm not intentionally coating it with glue. I want to do this as quickly as I can. Come on, baby. All right. A little bit on both there. Bring them together. Give it a little initial push with your hands to help keep it from wanting to slide once you get the clamp on there. Then put your clamp directly across. And loosely, or gently, not loosely, loosely tighten, gently tighten. So I've got just a little squeeze out happening now. That's it. 9:34. Okay? Do your opposing sides. Let them dry. And then once they're dry, I'll show you how to take off the glue pads, because if you just try to rip them off, you're gonna destroy your fibers. It's gonna tear, 99% of the time, it's gonna like tear out some of your wood. So there is a way to do it to avoid damage, but I'll show you that after this dries. So, questions? We'll be back. Resumed. Okay, this has been sitting for an hour-ish now, right? Everything's all good. The thing to do is to cut on the outside of what you're looking, of that joint. I don't want you to cut through the glue. You could cut through it, the hot glue, if you're using a handsaw, but even then it's gonna muck up your surface really badly. So what I usually do is I go to the bandsaw and I cut outside of that line by about 1/8 of an inch on both sides. I'm gonna do that really fast. I will be right back. I have actually only left about 1/16 of an inch of material here to the outside. So not much at all, right? Not much in the slightest. But still very, very clearly the outside of that glue line, right? Everyone can see it. Right? Then I'm gonna take my iron. If you cannot find an iron, typically there's one in the or in the tool room. If you can't find it, it's going to be in the advanced classroom. Just ask. I can let you in. I can find one for you. But go ahead, put your work in a vise. Heat it up. All I'm doing is remelting the hot glue without actually putting hot glue on this surface. It should, ooh, look at that, pop right up. And then if there's still glue on that surface and you don't have, you don't want to just iron it off like that, put something over it, like a piece of paper or whatever, and you can kind of lift it away as you go. Would you hand me that spatula there? I also will sometimes use a glue scraper or a utility knife blade or something to get the majority of the material off. I'm just trying really hard not to damage my fibers here, at least past the point where I'll be able to easily sand out any problem that there might be. And if you tear the fibers out, which is what happens if you just try to break it off, that can really suck. So remove the majority of it. And then you can, kind of slowly but surely remove the remainder. And then I can sand the rest of this off. But, much, much better than destroying a bandsaw blade just by cutting through your glue. Cool? That's it. I'm just going to do this on this side real quick. Once more for good measure. And if you do find that you have messed up this surface for whatever reason, don't just leave it there. Please, please do me a favor and clean it off. You don't have to, you don't have to do the clean function or anything like that. You can take either steel wool and clean it off or oven cleaner or some such thing. Ooh. Sometimes I'll even take that same piece, look at that, just clear off the vast majority of it in one go. But yeah, don't leave it for somebody else to destroy their fabric by putting an iron covered in crud all over their thing without noticing. All right? Awesome.